Node.js powers an increasing number of applications in the modern web. As Node's popularity grew, NPM evolved in parallel as its default package manager, and it has become a robust system for sharing and developing Node programs. And yet, today NPM is growing beyond its roots and is poised to become a generalized framework for all kinds of workflows within web development. Today's guest, Laurie Voss, is the CTO of NPM, and he joins me on Software Engineering Daily to explain how NPM has evolved over time to incorporate more than its initial vision. Laurie will be giving a talk at O'Reilly's Fluent Conference called Beyond NPM Install, the Many Uses of Npm. And before we jump into my conversation with Laurie, a quick word about the sponsors that support Software Engineering Daily. I love being a software engineer because of how easy it is to build side projects, and I've built countless side projects. I've built a social gambling application, a dating website backend that had 0 users, a stock trading music rhythm application for Android, and I think every developer should have side projects. So when I have a web app that I want to deploy and share, I want to show my friends my most recent project that nobody will care about, I use DigitalOcean to quickly spin up a server and host my projects. And who knows, if one day one of my apps takes off and goes viral and people actually do care, I can easily scale using DigitalOcean's flexible pricing plan. Companies like TaskRabbit that have grown rapidly have used DigitalOcean for this very reason. But until this happens, I will happily stick with the $5 a month plan. Sign up with promo code SEDaily to get a free $10 credit as a listener of our show and start building your apps. We would love to see what listeners build, so send us an email showing us your project. I've also interviewed Moisey Uretsky, who is the co-founder of DigitalOcean, and he mentioned that the ease of use and the flexibility is why they built the service in the first place. That DigitalOcean interview is one of my favorite episodes. Moisey talks about bleeding in a data center. He says, you don't know how hard it is to do a cloud hosting service until you've bled in a data center. It's really interesting. So speaking of which, let's get on with this episode of Software Engineering Daily. Laurie Voss is the CTO of NPM Incorporated. Laurie, welcome to Software Engineering Daily.
Hi, pleased to be here.
Let's start with a naive question. What is NPM?
NPM is the package manager for JavaScript. It started life as the package manager for the Node.js ecosystem, but in the last couple of years has become much more of a general tool. I can go into what is a package manager if you'd like.
Sure, let's start there.
So one of the hardest problems in programming is code reuse. And one of the things that Node in particular is good at is code reuse through the use of many small modules. Once you've adopted that pattern, though, you have a new problem, which is that your code in all of these small modules needs to be shared. It needs to be shared across projects. It needs to be shared across the world. It needs to be shared within your company. And once it's shared the first time, you need to keep it up to date. In the early days of Node, this was a huge problem. People were emailing each other gists and diffs and saying, like, go to this website and download this zip file and over to that website and download this tarball and glue them all together and make sure that they don't conflict and blah, 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 blah. And making sure that your dependencies were in the right place, up to date, and not fighting with each other all the time is basically, those are the 3 things that NPM absolutely nails and has done since its beginnings.
Great, and we'll go into each of those. The first one is that NPM was created to improve the distribution of code. And you obviously mentioned the worst case distribution of code, which is like emailing each other tarballs and stuff. But what are the different ways in which code gets distributed across the internet, perhaps that are a little more sane than things like that?
Well, most modern languages or runtime environments have some sort of package management at this point. Perl was the first out of the gate with CPAN, which was a repository. It was one half of the package manager. It was where all the packages got uploaded, but it didn't really have a dedicated client to download them. You just sort of, downloaded and installed the stuff into your project. PHP in its early days had Pear. Obviously, all of the Linux distros have had package managers since forever. Red Hat Package Manager and Yum and apt and all of those. They're all obviously Ruby gems. They're all strikes at the same problem. A lot of them have problems that are sort of intrinsic to the environments in which they run. A lot of the advantage of using NPM or the convenience of using NPM is the fact that you never get into this problem referred to as dependency hell. You never get into this situation where A requires B and C requires a different version of B, and the two of them can never meet, and they can never use A and C at the same time. That doesn't happen in Node. And the reason that doesn't happen in Node is because Node was written specifically to make that impossible. Node and its package manager were written at the same time by the same people, which is a completely unique feature of a runtime environment. No other runtime environment was written with the expectation that there would be a package manager, and therefore you should make it easy to manage packages.
Right. So you've touched on this idea of dependency hell, and you've defined it. Why was dependency hell so prevalent in the JavaScript world of development?
I'm not sure that's the correct premise of the question. It is why isn't it so prevalent in the world of JavaScript? Because it's prevalent everywhere. You get dependency hell in all runtime environments. You don't get it in Node because Node was built to avoid it. It was built with the expectation that this would happen. And as a result, the reason Node is a more modular landscape, the reason that many small modules as a philosophy caught on so much better in Node is because you could get away with it. In other languages, everyone's always known that using lots of small components is going to be better. But in languages like, C or PHP or Perl or Java, having lots of libraries is really painful. Installing any particular library is always going to be this huge ceremony to make sure that it's not conflicting with anything else. And so they tend towards monolithic libraries, like 2 or 3 per project, just because 2 or 3 is about as many as you can stand the pain of installing. Whereas in NPM and Node, it's routine. It's absolutely expected that a big project will have a couple thousand dependencies, which is... And the reason that happened is because there is no dependency hell.
So you touched on the fact that this was possible largely because NPM was developed at the same time that Node was developed. So I'm kind of curious about how the communication process worked across that development period of time.
So I should definitely include the huge caveat that I wasn't there at the time. I was not the person who was building it. Isaac, my CEO, is the inventor of NPM who put this together. But I've been in the room when he explains history long enough that I can say that at the time it was a very easy way to do that communication, just because there were only about 10 people in the world who knew about this thing. So it was Isaac was writing NPM and Ryan Dahl, who invented Node. They were good friends and they spoke every day and they lived in the same city and they could meet each other. And that was how that happened. It was collaborative by default.
So how is this? Let's say what were the things that Node and NPM were able to? Were there any like silver bullets that Node and NPM, being built in parallel, were able to improve upon when you think about NPM relative to other package managers like apt or RPM or whatever the other canonical package managers?
Absolutely, and I've touched on it already, which is the reason dependency hell is impossible in Node is because Node was written with the expectation that NPM would be there, putting packages into a certain place. The Node modules directory and package JSON are actually expected by Node. They are the thing that defines a Node module is part of NPM, and it is also part of Node in a way that is completely unique to that environment. So literally, Node pulls stuff into memory, and its unique feature is that it can pull two or more versions of the same library into memory at the same time and run them at the same time without conflicting with each other. And it does that because it has the expectation that NPM will have put them on disk in a pattern that it can predict, such that it can load them in the right order, such that the right one will be hitting the right piece of code without conflicting with each other, or without running version 1 when you were expecting version 2. And it's I was going to say it's a relatively simple. It's an extremely complicated piece of code, but it's a relatively simple concept to get that to happen, but it's only because they were written. Node was invented after package managers became popular that it was an idea that somebody should do that.
Great. Okay, so I want to get into a more granular level of the topics that you're going to be exploring in your Fluent 2016 talk, and the talk is called "The Many Uses of Npm." So to begin with, how do people use npm commands to get started with a project?
So the thesis of the talk is that 95% or maybe 90% of npm users know about npm install, and that's all they know about npm. They just run npm install. They know that it brings down a library and puts the library in place, and they're unaware that there are any other features of npm whatsoever. Which is, both a good and a bad thing. It's great that we built a tool that doesn't require you to know anything other than one command to be an extremely useful tool. But it's also a problem for a team of people who spend their whole lives making sure that all of the other things that npm does work, if 90% of our users aren't aware of them. So the purpose of the talk, or the thesis of the talk, is that npm is not just a tool that you use to kick off your project. It is a tool that you use at every point of the life cycle of your project. So there's commands, as the most basic one, there's npm init, which starts your project. A lot of people start an npm project by manually hacking a package JSON together, and that is what npm init will do for you. It will just ask you a bunch of questions and do it for you. But there's npm publish will put stuff on the library, on the registry for you. But there's also stuff like npm run scripts where you can do stuff like npm test, npm start, npm run any random word that you like, and you can build in lifecycle chunks of your code. So if you have a command that you run all the time that resets your test fixtures, or sets the testing database back to 0, or any other ordinary development task that you need to share between all of the developers on your team, and you would ordinarily write like a wiki page saying, when you need to fix this problem, run this command, or when you need to do this thing, write this command, you can just build it into the application itself. The application knows how to take care of its own life cycle because you can just build that into package JSON and thus into npm itself.
Okay, great. So what kinds of npm commands are useful for improving like a testing and deployment workflow, or how should people architect their testing and deployment workflows around npm?
That is a deep and complicated question, and I do not think it would be wrong for me to say that there's one answer to that question. I cannot possibly say this is the way you do testing with npm, because even within npm Inc., I would be shouted down from all sides were I to pick one way. The crucial advantage of npm is that you can use npm's lifecycle hooks. It has things like pre-publish and post-install and pre-version scripts that you can hook in, and they will happen at lifecycle events. So you can make it such that it is impossible to publish a new version of your package unless all of the tests pass. You can just build that into the workflow. And it just becomes part of everyone's life that they know that this happens. You can one of the things that we've done all the time is we put linters into the pre-publish hooks of our packages. So every time you publish the package, it reformats the code of the package such that it meets the NPM style guide or one of the NPM style guides. We have, everybody gets to pick their own. But it had this really fantastic effect that it meant that code reviews turned into a completely different animal, because there was no longer the sort of lazy code review where people would go, oh, you've put a semicolon in the wrong place, or I don't like this formatting, or this variable isn't used, or your callback might not get called, because it's literally impossible to publish a version of our packages that has any of those problems. So instead, our code reviews had to be much deeper and more complicated things where you were like, well, this approach looks interesting, but there could be a more important way. And that's basically what NPM does across the board, is NPM reduces the amount of communication that is required to do ordinary things. You no longer have to tell somebody the command. You no longer have to remind them to run their tests. You no longer have to give them elementary code reviews. You can automate all of that stuff away and get on with the complicated parts of programming. That's what NPM is trying to do.
So the assumption that people make about NPM that you kind of said a few minutes ago is that you only use NPM just to install stuff, and it's too bad that people make that assumption, but at the same time it's kind of a fair assumption to make, because the way that we have historically used package managers, or at least the way that I've used package managers in the past, is generally for that purpose. So how can we start shifting as a developer, how can I shift my paradigm to thinking of NPM in the more the wider scope that you, for example, see it?
That's an excellent question, and I think the answer to that question is not simple, and it's sort of crucial to the future success
Is it a question for the marketing department?
It's a question for the person who writes all of our documentation, for sure. But it's crucial to the success of both the NPM ecosystem and NPM Inc. as a company, that people become aware of the wider universe. I think there's a diagram that I draw that it's part of the talk. Is it starts at install, and it's a sort of series of chains of life cycle. Sort of this is you going off on the install flow. This is you going off on the publish flow. This is you going off on the deploy flow. And the deploy flow is like this series of question marks, because there's a couple of things that NPM sort of does, but not perfectly, where it gets dicey, like shrink wrap. Shrink wrap's a really good idea in theory. The idea of shrink wrap is that you go, in development, I want to use semantic versioning. In development, I always want to bring in all of the patch versions because they're going to be safe. And I usually want to bring in the feature versions because new features are fun and the developers promise that nothing is going to go wrong. But in production, you probably don't want to just work on promises. In production, you want to be like, I want the exact snapshot of what is running right now and working on my development environment in production, and that's all that I want. That's what shrink wrap is supposed to do. And it does it most of the time. But it definitely has some edge cases where it breaks in a really painful way. And that means that we can't just blanket say, and you deploy your stuff with shrink wrap, because we know that you can't sometimes deploy your stuff with shrink wrap. We know it will break sometimes. So that's one of the things that we are focusing on for NPM in 2016. We have a big list of them, but one of them is NPM works every time, and it works the same every time, because we want it to be completely predictable, completely understandable, totally unsurprising, such that you're not scared of using NPM to run your entire workflow. Because one of the things we said very early on is that NPM exists to reduce developer friction. That's why people like us, is we just make it easier to get stuff done. And if we're not completely reliable, then we are introducing friction. We're not taking it away. So it's a focus for us.
So just to go further into this question, before I started researching for this interview, I just thought that NPM was just a package manager, but it seems like the vision for NPM is so much bigger. It's more like bash scripting or Chef. And so I want to make sure that I'm correct about this being the current vision, and if so, I'm curious if this was the vision from the beginning.
It's not. I would say saying that it's like bash scripting or Chef is an overreach. The NPM run scripts are written in JavaScript or Bash or whatever you were running them in before. If you wanted it to run your Chef scripts, it could. NPM is much more like a framework for a workflow. It's not defining the pieces of the workflow. It's not saying this is how you run your JavaScript, and it's not saying this is how you should make a website, or this is how your API should look. We're not Rails. We're not prescriptive. What we are is we are aware that software works this way. You start a project, you install dependencies, you run it, you test it, you deploy it, you fix it, you add features, you occasionally do breaking changes, and we know how to do all of those things. And however it is that you do all of those things, we know that you have to chain them together in the same way. So we will be the framework by which you chain them together. And we will get out of your way. One of the tools that we came across recently that we think is fascinating is this company called Greenkeeper. And what they do is they hook into the NPM changes feed. So they watch every single package being published. And if you tell them what packages you own, they will tell you when your dependencies changed. They will say, these 3 packages that you depend on have changed. Now you know. And you can either, pull in those changes or update your packages or change production. It'll tell you the change log. It'll say, this was a security fix. You probably really want to do this one. And that's exactly the kind of use case that we like for NPM, where we are just the mechanism by which people are reducing communication. You don't have to go to those libraries and read their web pages to discover that they had a security alert. It just happens automatically. Just get an email saying, hey, time to hit the update button because this one's scary. That is the kind of reduction in friction and reducing of human communication that we really think adds a bunch of value, and it's what we like. We're developers. We want to just be writing code all the time and not having meetings, and NPM is really good at that.
So I think one example that describes this goal that you just described is that NPM can be used to manage the workflows of different teams. So if I have 3 teams, like a web team and an API team and a QA team, how could I use NPM to improve the workflow between these teams?
Well, we have a very concrete example because NPM does have a web team and an API team and a support team, and they do communicate via the medium of NPM. We have modules within the company that do stuff that are common to the various bits of NPM. NPM is not itself a monolith. NPM, the service, is a series of disconnected microservices which are talking to each other all the time. So we know when team registry publishes a new version of the module which validates what a package should look like, that the CLI team can pull in the new version of that module and go, okay, well now the CLI should be validating the same thing that the server is going to validate, because otherwise it'll be possible for the CLI to blithely attempt to publish something that the server will then reject. But those teams don't need to have meetings about that. That just happens. And in the same way, the team that works on the website can change how usernames are validated or spell checked or whatever it is, and that stuff turns up in the registry side as well. So does that answer your question?
Yes, it does. And just to give one other example of how people can use NPM before we get into how NPM works at a lower level. some people use npm to actually manage CSS, and I think this is maybe part of a discussion we could have later on about how what is the big vision for npm. But explain how people are using npm to manage their CSS.
So I said at the beginning, we are no longer the package manager for Node. We are the package manager for JavaScript. And that was not like some, crazy meeting we had where we were like, let's let's swing for the fences and do all the JavaScript. It was very much an NPM-y sort of get out of their way type thing. People were using us for front-end code, whether we liked it or not. It was just happening. And so we decided to get the hell out of their way. And CSS was one of the ways that they were doing that. There is a project we quite like called Dr. Frankenstein, which it was being used at Pivotal, I think, and it basically modularizes your CSS. So you can write, if you have a very large CSS component library that is sufficiently put together that you can bring in your components independently, but on any individual project, if you're Pivotal, you have lots and lots of web projects and you're using the same tools. So on this tiny little mobile site, you're only using 2 components, but on this big CMS site, you're using 50 components. So whichever components you're using, you can just npm install that chunk of modular CSS and it works. So that's one of the ways it can be done. There's a couple other ways. There are a bunch of third-party modules that will let you npm install just chunks of CSS, and in some cases chunks of HTML and JavaScript as well. You can just, I think there's it's like a calendar widget or something. It's one of those canonical widgets that people invent over and over, where you just install the widget and it's done, and suddenly that widget's available in your web app. The use of npm to be the way you build websites is something we absolutely are committed to doing. We don't want it to be the way you build websites in the way that Rails was the way you build websites, like structure your code this way. We want it to be the default tool for web developers. Like, we want the first thing you do when you're like, all right, I'm going to build a website today, to be npm and go. Like, whatever it is, we want to be the way that you do that. We want to be the framework on which all of those tools hang, just because that's the thing that we've seen that is useful.
So, can you delineate that further? So how would that differ from what the Rails CLI tool would do?
So the Rails CLI tool is a tool that lets you build a Rails application. It's expecting a model view controller application with your templates here and your CSS here and your views here. NPM is a much smaller concern. NPM is just, if you wanted to start your project, this is how you would install your dependencies. If you wanted to run it, if you wanted to test it, if you wanted to bring in other dependencies working with each other, you use NPM to bring them in. You wouldn't necessarily say, this is the way you build your website. That's a change for me personally. Like, my background is as a web developer. So when I came into NPM 2 years ago, I was like, all right, we're going to find the best web framework and we're going to pick it and we're going to evangelize the hell out of it. And this is going to be how it's going to go. And I felt like that for a good 6 months until I realized that the thing about Node that makes it good, the thing about Node that makes it different from, say, Ruby, is that nobody wants to pick a winner. And in fact, that is its strength. There is no one way. Nobody says this is how you do it. There's probably going to be less than there are now. Like right now, if you want to build a website, here's 10,000 frameworks, pick one.
It's a Cambrian explosion.
Right. I think there's going to be a lot of consolidation. There's going to be a lot of merging of projects or at least cherry picking of the best features. And I think we're going to shake out with somewhere between 5 and 10 major use cases. So like the pure API play, the full-on WordPress-esque website where you just install individual chunks of functionality, but it always works the same. The middle ground where it's like Express and you're like, we've got this feature of a web app, but it doesn't say what the web app should look like. And a couple other points on that spectrum. So there's Sales, which is exactly like Rails, which is that's a point on that spectrum. And sales isn't going to be the thing that wins. And in fact, nothing's going to win. It's going to be this set of tools that cover the major use cases for building something that is on the web. And I think that's fantastic. I think that's much closer to the reality of how people build web apps.
Yeah, and this reminds me of the conversations I've had with people from the Facebook team. You know, they're working on projects like React and Relay and Flow. And I remember asking, I think it was Ben I forgot his last name, but Ben something, this will be in the show notes, so why isn't there some sort of one React tool to bind them all to, give me this wonderful packaged experience that tells me how to do everything in React? And it was very clear from the conversation that they want it to be loosely coupled, and they want people to be able to pick from things like it's a buffet. It's not like, you've got this set of dishes that you're going to be served. It's you choose what you want, and hopefully they all work together in a nice, convenient way that is as expected. So let's talk some about how NPM works. Just from a basic level, when I use NPM to install a module, what happens?
Well, the most important thing is that it hits a bunch of servers that we run that have all the tarballs on it. One of the most surprising things about working at NPM is your discovery that there are huge chunks of NPM users who don't understand that there's a registry there at all. There's a huge chunk of users who think what NPM does is it downloads your dependencies from GitHub for you. And this leads to some really fantastic support conversations where people are like, I published the new thing to GitHub and it's not on NPM. What's wrong with you? Why are you broken? And we feel like you missed the step where you put it on our servers. And we frequently get this complaint from two directions. One is, why are you running a registry server? You should just download everything from GitHub. And we were like, well, GitHub goes down sometimes, not often. They're pretty good at their jobs. But other times we get it the other way, which is like, why would you run a bunch of servers that could go down? And it's true. NPM famously used to be down all the time. And the answer is it's much faster and it's much more convenient if it is on servers that are set up in exactly the way that NPM is expecting, so that it works exactly the way the client works and can do all of the complex versioning stuff that the client can do. But to get back to your question, the life cycle is quite important, because this is a thing people don't understand. When they see NPM hitting the network all the time, they're like, why does it download everything every single time? It hits the network all the time, but it doesn't download everything every time. What it does is, for every single package, it asks the registry, is there a new version of this package? If there's a new version of the package, it downloads the package. If there isn't a new version of the package, it loads it from the cache. There's a global cache on every computer that has NPM installed, which is all of the modules you've already installed. So one of the reasons it looks like it's hitting the network all the time is because it's hitting the network all the time, but it's making 304 requests. It's making these very quick, light rate requests, which is there anything new? And the answer is just no. And it moves on to the next package. But also, when you have 1,000 dependencies, the chances are that between you running npm install one time and a week later, maybe 50 of those will update. It genuinely does have new stuff to download all the time. If you're following Semver and you're allowing patch versions to come in all the time, 50 patch versions out of 1,000 packages is actually a pretty good percentage on a healthy ecosystem. So it's downloading new stuff all the time because new stuff has happened. So that's the first part of the life cycle. It's this chain of 304s and 200s as it pulls down either notices that nothing has changed or stuff that has actually changed. It unpacks those to a temporary directory. It makes sure that the tree is the way that it needs it to be. And then it puts it into your node modules directory as a single atomic step. I am radically simplifying here.
Cloudinary is the image backend for web and mobile development. As web and mobile development have become more about images, you might have found yourself frustrated. manipulating images, uploading images, trying to optimize their delivery in your website or in your mobile app. Cloudinary makes software development with images simple by combining the speed of a CDN with an API for tasks such as image manipulation, uploading, storing, facial recognition, and of course, fast delivery for any device. Software Engineering Daily loves showcasing products like Cloudinary because it is so focused. It provides a great experience both for developers and the end users of those developers' products. You can try Cloudinary's image manipulation easily by going to cloudinary.com. You can upload an image of a cat, for example, and resize it by simply changing the URL. Now that is a rich image API. Cloudinary is used by companies like Dropbox, Gizmodo, Fiverr, eBay, Lifehacker, many more. These companies obviously have tons of images and high demand for how they want to manipulate and serve their images. Cloudinary is also a proud sponsor of O'Reilly's 2016 Fluent Conference, which is March 8th through 10th in San Francisco. And Software Engineering Daily is giving away a free ticket to Fluent. To be entered into a drawing for this ticket, tweet at software_daily about your favorite episode or tell us why you love Cloudinary. Thanks again to Cloudinary. We are proud to have you as our newest sponsor. Okay, well, you mentioned the global cache. What is the interaction between the global cache on my machine and the different applications I have built on my machine that use packages in the cache?
So the cache is used at install time and only at install time. For any individual Node application, your Node modules directory is where all of the packages you're using at that specific time live. The advantage of this is that if you are in Project A and you install a new version, you cannot accidentally install a new version that makes Project B break. Project B installed all of its modules and it was fine, and it's still fine. And Project A, which is you ran a week later, had a bunch of new dependencies, and it brought those in, and they still work fine as well. So everybody's local Node modules copy is completely independent of each other. The only thing the global cache is used to do is to reduce the amount of stuff that you download when you run npm install. If you're running npm install and it's like, you installed this last week and 99% of these packages are unchanged, it's all going to come from one portion of your disk to another portion of your disk and be super, super fast.
So the npm nomenclature for where the packages live remotely is registry. Is there an actual difference between the term registry and repository, or is it more just like a contextual thing?
I mean, it depends how much of a pedantic nerd you really feel like being, right? Like
I'm a pretty big one.
A repository is a monolith. It is, everything has been crammed into here, and it is, like a Git repository is a pile of stuff that is all connected to each other, whereas the registry is an index. So it's not saying, this is the current thing, here you go. A registry is, here's a list of all of the things. Pick the one that's relevant to you. Most of the time when you're using NPM, what you're really doing is you are taking a slice of the registry. Every registry package has a set of tags associated with it, and the latest tag is where nearly everybody lives. When you say npm install, what you're implicitly saying is npm install the latest version of everything. But that's not what the registry contains. And the registry contains every version of everything. It contains all the versions you ever published. So if you want to go, give me the pre-release versions of everything. Give me everything that isn't deprecated. Give me everything that is currently in beta but is marked as being stable. Give me, nightly builds. Though, depending on the sophistication of the authors of those packages, those can be meaningful tags.
So as we've discussed, Node avoids dependency hell, partly with semantic versioning. And I won't ask you to go into extreme detail about how semantic versioning works, but are there any tidbits or elements of semantic versioning, or as you call it, semver, that developers should know about that would be helpful, maybe when they're debugging some sort of some sort of issue, what is useful for a developer to know about Semver?
I think the most interestingly simple but incredibly useful thing, I can't remember who threw it at me recently. I think it was AG Dubs who writes our documentation. She said, we always talk about Semver as being these three numbers separated by dots, and we say major, minor, and patch. And to understand Semver, all you have to do is change those words. Instead of major, minor, and patch, use major, feature, and use breaking, feature, and fix, because that's what the numbers are. If the first number changes, it's a breaking change. If the second number changes, it's a feature. It's added a feature, but it's not broken anything. And if the third number changes, no functionality has changed. There's no new feature, but there is something fixed. So if you allow the third numbers to change, all you're ever going to get is the current functionality slowly being more perfect. If you allow the second two numbers to change, you're going to get new features occasionally, but nothing's ever going to break. And if you allow the first number to change, it's because you are expecting to have to do some work. You're deliberately bringing in a breaking change. You know that something in your software is going to have to be upgraded, and you've decided that's okay.
So I want to zoom out and talk about the bigger picture and perhaps some common misconceptions. So we've done a number of shows about JavaScript technologies, including Node. You've pointed out the difference between JavaScript and Node, and you've emphasized in a talk that I saw that Node is a runtime. Why is this distinction important, and what does this term mean, a JavaScript runtime?
So it's one of the trickier semantic problems of living in Node land, is that people think about Node as being a language, but it's not a language. JavaScript is a language. And JavaScript running in the browser and JavaScript running in the server, they share a syntax, but there are some very important differences between them. And the only way to describe those differences is to say the runtime is different. The runtime environment in which JavaScript on the browser executes is very different from that of Node. The biggest and most crucial difference is I've repeatedly said that Node doesn't have dependency hell. Node, the runtime, does not have dependency hell. JavaScript absolutely does. JavaScript in the browser can have dependency hell. If you import two libraries in your browser and they fight with each other, they will fight with each other and they break. And there's nothing that NPM can do about that. There's nothing anyone can do about that. That's just how browsers work. So that's why when we're saying that Node is the runtime and Node as a runtime has this great feature, it's because we are limiting the scope of our claim of magicality. We're saying we will solve this problem for you, but we can only solve it for you on the server. We cannot fix how modules work on the browser. ES 2050 and ES6, the new versions of JavaScript, which no one can agree on a name to call, they have a module syntax and they have semantics about how this should work. There's still a fair amount of disagreement about how they should work exactly. The most obvious evidence of that being that if you ask anybody if there's disagreement, they'll go no, but they won't actually have said the same thing. They'll say everyone agrees X, and if you ask somebody else, they'll go everybody agrees Y, which is the worst kind of disagreement because they don't even know they disagree.
Yep. To reiterate our discussion from the beginning, why does JavaScript need a package manager?
JavaScript needs a package manager for all the reasons that Node needed a package manager. Web development as an industry, as a profession, is a relatively young one, and it's beginning to mature, and people are beginning to realize that maybe re-implementing my entire web app from scratch every time is kind of a pain in the ass. And that problem was brilliantly solved by Rails on the server side. I'm not a big fan of Ruby on Rails. I'm not a big fan of Ruby, but one of the things that it did was it introduced to web developers and web development as a profession this idea that all you need is a pattern. It doesn't need to be the best pattern. It doesn't need to be a fantastic pattern that fixes every problem, but as long as you have a pattern that people can follow and use as their default, then suddenly everyone's more productive. You hire an engineer and you go, it's a Rails app, and suddenly the first 6 weeks of their life at their company are gone. They don't need to, you don't need to train them on how their templating system works and how the model controller works, because it's a Rails app. They've worked on a Rails app before. And the reason that you need a package manager for front-end JavaScript is because that's going to happen. That is already happening for the complicated client-side single-page apps that people are building in huge numbers these days. There's Ember, there's Angular, there's 8 zillion other frameworks, but they all have the same problem that server-side had, which is that they have tons of components and they're very modular, and you need some way to be able to share them between each other. And NPM cannot fix dependency hell, but it can absolutely tell you where your modules are and put them into disk in some sort of predictable way. So we can solve that problem for the browser.
And how does the world change if we get a package manager for HTML and CSS along with this package manager for JavaScript?
I think it will, if we do it right, it will be the same world but faster. That's what NPM is doing for the server. Is people talk about how much faster Node development is, and it's not that Node itself runs faster because it's JavaScript, which is, it's a performant language, but it's not high performance. What's faster about working in Node is the team. The team works faster in Node because there's less friction, because they don't spend an hour a day installing dependencies or fighting with each other about what the run script is. Because all of that stuff is abstracted away or automated away by NPM, Node teams run faster. There's a case study we use from PayPal, and it's a brilliant case study because they literally had two teams building the same thing. They were like, we're not so sure about this Node thing, and we're PayPal, so we're gigantic. We can throw two teams at exactly the same problem at exactly the same time. And the Node version of that project was finished in half the time using half the developers and used like a quarter of the hardware. It was better on every metric. And that's what you can do for the front end. If it's not that Node is a super fast runtime. It's that having package management makes your team work together more smoothly, and that makes your development process faster. So bringing that to the front end is exactly as useful as bringing it to the back end.
It's worth pointing out here that NPM is both a package manager and a company. What is the company NPM, which you are the CTO of? What does NPM do?
Well, it's a complicated question. First and foremost, the reason we formed a company, the reason that the problem statement Isaac came to me with when he was like, I think I need to turn this thing into a company, is the registry is too big to survive on the generosity of its users. We know from our conversations with the other people who run package repositories that running it based on donations is a nightmare hellscape that you don't want to get into. There's too many people, there's too much bandwidth, there's too many servers. The purpose of NPM Inc. is to make NPM run forever. That's what it's supposed to do. And the way that you do that is you wrap a business model around it. You go, this is the precious egg that is NPM, and to keep it going, we have to cushion it in a pile of money. And so we could just, beg our users for money. Like that happened a couple of times in the early days of NPM, but it was not as sustainable, and it created weird tensions. Whereas, giving you services for money, that's a thing everyone can get behind. People understand how that works. So that's what NPM Inc. does. NPM Inc., it adds one feature to the registry, and that feature is privacy. It says, if you want to share your code with the world, that's free. If you want to share your code with just the people inside your company, that's the bit you pay for. Just a couple of people, that's the bit you pay for. So that is what private packages is. That's what the orgs product is. That's what NPM Onsite are. They are just different versions of how you want to share stuff privately.
So I think these combination open source plus business model companies are super interesting. I've done interviews with people from a lot of these different companies, like Confluent for Kafka and Cloudera people, and it's always really interesting. So could you tell me a bit about your work as CTO of NPM?
So first, I'd like to draw a distinction between us and some other open source companies. There's a pattern of running an open source company, which is we built this server and we run this server for you, but you could also run this server for yourself in exactly the same way. That is true. You could run your own NPM repository, but we are different in that we are also the registry, and a huge chunk of why NPM is valuable to the world, it's valuable to its users, is because we are literally the world's largest repository of, I think, software of any kind at this point. Like, we just have so much more than anybody else. So you could run your own NPM server, but it's not really any use unless you've got all the modules. That's what we're doing, is we're taking care of the modules for everyone and making sure that it's not full of junk. So that's a big part of what we do. But you had a more specific question, which is, what do I do as the CTO? And that is a more complicated question, because that answer has not stayed the same for more than about 3 months at a time. For the first 3 months, I was doing nothing but fighting operational fires, because the registry was just down all the time.
Oh.
For the next 3 months, I was writing the next version of the registry. For the next 3 months, I was drawing architecture diagrams, because we'd hired a bunch of people and they needed to write the software, and I just needed to say what it looked like. For the next 3 months, I was just hiring. For the next 3 months, I was just managing people. For the next 3 months, I can't remember what stage of the company we're at. Now what I do, the last 3 months have been defining products, because there's now enough of us going on, and there's enough people writing software, and there's enough people managing the people who are writing the software. The thing that we discovered was the thing that most needed doing, was saying, what is it and what does it do? And importantly, what doesn't it do? Because we now have so many smart people coming at the problem from every direction, that saying we're not going to do that yet is a big part of what we're doing as a company, staying focused on this is the most useful thing we should do.
Fascinating. Well, it sounds like you've been, at least you don't get bored.
It's the thing about being a founder. I don't think the average CTO would say my job changes every 3 months. It's because I'm also the founder. It's like the founder does whatever the hell needs to be doing. And so the CTO title is kind of nominal for me.
Oh, okay. Okay, so final question to wrap up. Where do you see web development going more generally? Like, do you have any like really hyper ambitious, counterintuitive things I probably haven't heard before that you can tell me about your vision for where web development is going?
I think if it was something that you'd never heard before, then it would be almost certainly something that's not true. I am not some visionary genius of web development who's like, 10 years from now, we're all going to be using React on the server. Like, who the hell knows? I think the thing that is already true that not a lot of people have fully embedded into their consciousness is the dominance of mobile. I think a lot of people who are web developers, especially people who've been web developers as long as I have, they still think of mobile as that thing that would be nice to have, but really what I'm building is a thing that you look at on your laptop. And that's just demonstrably not true. 50% of all web traffic in the US is on mobile. That's on phones. Outside the US, it's like 70 or 80%, depending where you are. The web is a thing that we experience on screens that are 4 inches wide. And the effects that has, the ramifications that has for the stuff that we should be building and how fast it can be and how complicated it can be, we're not thinking about that enough right now.
So when people architect their apps, maybe they think a little bit too much about the front end, the web front end, and then think about the mobile as an afterthought, and maybe that's an anti-pattern.
Absolutely. I think in particular, it's kind of a problem for people who are building single-page apps, because one of the things about single-page apps is that they use a lot of processor and a lot more bandwidth, And people are like, oh, that's fine. Connections are mega fast and everybody's laptop is a supercomputer. I'm like, that's true. But this thing happened where people stopped using laptops. And half of your audience are on this really tiny, crappy computer. And so the fact that it doesn't matter on desktop, you're right, it doesn't matter on desktop, but desktop doesn't matter. It's what does it work like on a phone? Your constraints are primarily those of a phone. And how it works on a desktop is just nice to have.
Okay, well, that seems like a great place to close off. Laurie, thanks for making time to come on to Software Engineering Daily. I look forward to seeing you at the Fluent Conference, and I will have a t-shirt to give you for sure.
And we'll have one to give back to you.
Oh, thank you. Wonderful.